on electromagnetic theory. The fact that a time-varying magnetic field can produce an electric field was proposed by Faraday. Then James Clerk Maxwell confirmed that a time-varying electric field can produce a magnetic field also. This brilliant idea unified two different branches of physics, electricity and magnetism, through electromagnetic theory. Before going to the basics of electromagnetic theory, we need to have a clear idea of vector calculus. For that, I am going to introduce before you a vector operator known as the del operator. The del operator can be defined as del is equal to I dou by dou x plus j dou by dou y plus k dou by dou z, where I, j, k are the unit vectors. This operator can operate upon a scalar and the resultant will be a vector. That is, del operating on a scalar function will give the gradient of that function or simply the grad of that function. That is, del operating on a scalar function psi will be equal to I dou by dou x plus j dou by dou y plus k dou by dou z operating upon a scalar function psi gives I dou psi by dou x plus j dou psi by dou y plus k dou psi by dou z. You can see that the resultant is a vector which has x, y and z components. Thus, the scalar function psi is operated by a vector operator del. The resultant is a vector which is known as the gradient of function psi. Like any other vector, this vector also has magnitude as well as direction. The gradient of a scalar function represents the rate of change of that function with distance, or the magnitude of the vector grad psi represents the rate of change of psi with distance. The direction of that vector, the direction of grad phi, gives the direction along which the function has maximum change. There are different examples for gradient. An example for gradient is temperature gradient. As you all know, temperature is a scalar, but we can operate it with del, then it becomes temperature gradient, which gives the maximum rate of increase of temperature along any particular direction. Similarly, we can take velocity gradient in viscous flow, also pressure gradient in capillary tube that carries running fluid liquid, etc. So, gradient of any function is del operating on that function. The del operator operating on any scalar function, the resultant is a vector. That vector has magnitude as well as direction. Magnitude of that vector is the maximum rate of change of that function, and the direction of that vector will be the direction along which there is maximum change in that function. Examples are temperature gradient, velocity gradient, pressure gradient, etc.